Now, what if we want our function to perform its task with different values each time it's called? That's where parameters come in. Parameters are values that are declared in the function definition and get their values when the function is called. For example, the .split method takes in one parameter, and that's the string you're splitting it by. So in this case, it's just a space. Now let's create a function that takes in name as a parameter and prints a customized greeting message. We'll do def greet, and then inside the parentheses, we will type name, because we're specifying we want a variable passed in to this function. Inside the function, we can do some f-string formatting and just say hello name, just like this. And so what this is doing is when we actually run greet, we actually have to pass in a value now. So I can say Bob, and so it knows that since there's only one argument here, it knows that it's going to be name. And we are passing in name as Bob. And so now name is equal to Bob when we run this over here. And so it knows, okay, well, name was passed in, so I'm going to do hello, and then when we use this variable, it's going to be Bob because we passed it in here. And so we can run that, and it will print hello Bob. And we can run this again, Alice, for example, and then just run that again. Let me just expand this. We get hello Bob and hello Alice. Note that the name variable inside this function can only be accessed inside the function. It's private to this function, so if we created a variable called name outside of the function, there would be one variable called name and a different variable called name that's inside this greet function. In programming, we call these function variables that are local to the function. Variables that are available to the main scope of our program are called global variables. We've been using global variables the whole time before we started doing functions. When you want to modify a global variable while inside a function, we use the global keyword before the variable. So if we had a variable that was x and it was set to 10, and we wanted to set x equal to something like 2, we are not actually referencing this same variable. So if you want to actually edit a variable that is outside of our function, we actually have to use the global keyword at the top of our function and the variable name. And then we'll be editing this variable instead of a local variable. While it's sometimes necessary or convenient to use the global keyword, it's generally best to avoid using global variables inside functions where possible. Global variables can make your code harder to understand and debug because any part of the code can change their values, which can lead to unexpected behavior. Instead, it's often a better practice to just use function arguments like this and return values to pass data in and out of functions. So instead of just having greet like this, and then setting name equal to Bob, and then over here, name is equal to Alice, and removing this, just like that, it still works, but it's not a good idea. Because first of all, it's more code, we have to set name and then run greet, but also it's never a good idea to use global variables, because it can get confusing and sometimes you might run the function when a global variable isn't existing yet. Of course, you could have a name variable that's equal to Bob, and then pass in name, just like this, and that could be okay too. So we could have a variable called Bob, and set that to the string Bob, and pass in the variable Bob as the name parameter, and that's fine. We can have as many parameters as we want, separated by commas. Let's create a function that takes in two parameters, first name and last name. So we'll do the same example before, but when we define greet, we'll actually have first name, and then a comma, and then last name. Now we can print hello, first name, and then last name. And then we can greet Bob Johnson, for example, Bob, and then a comma to pass in the next parameter, Johnson. Python knows the order of parameters, because up here we specified that first name is first, and so when we actually use these variables within our function, we know which one they are because they were passed in. So we're passing in first name, we passed in first name as Bob, so it goes up here, right? And then it uses it inside the function, so this will be Bob and this will be Johnson. And so the order does matter in this case. And now we can see that it says hello Bob Johnson. And I actually added a comma here for some reason. I don't know why I did that. Let's remove that. Okay, there we go. Hello Bob Johnson. And we can do it again. Alice Smith, I guess. Run that. And we get the two outputs, just like that, because we passed in two values. So now when we call the function with two arguments, it uses them both in the greeting message. So let's make a simple calculator that adds two numbers. Let's define add numbers, and we'll have number 1 and number 2. Inside this function, we will just print out the value of num1 plus num2. And down here, we can actually just say add numbers and pass in 2 and 2. So this will output 4, just like that. And if we ran 10 and 300, we would get 310. And it's just adding these numbers together. We can do subtract numbers, and now we subtract the numbers together. Negative 290, we can do 10 minus 5 if we wanted as well. But the order matters, because if we wanted to do 10 minus 5, we wouldn't put 10 over here, and then 5 over here, because that would do 5 minus 10. And so the order does matter. But there is this thing called keyword arguments. Sometimes it's beneficial to specify arguments by their parameter name. So if you remember, arguments are when you're actually passing them into the function. Parameters are actually these values up here. Parameters are just the labels, or the variable names for the arguments. And so we can actually choose which one we access first and second and so on. And so with our previous example, where we greeted the first name and the last name, and we printed it, instead of having to do Bob first and then Johnson, we can actually specify which one we are accessing. We can actually choose the order. And you can also keep it in the same order when you do this as well. But keyword arguments are when you actually specify first name is equal to Bob and last name is equal to Johnson. These are the local variables for the greet function, and we're specifying which ones we're actually entering as the parameters. So if we actually had last name before first name, that is okay, because the function knows that the first item is actually last name, and the second item is actually first name. So we're telling it which one each one is, instead of just having to go for the order. And so it could be any order, right? And we get the two outputs, and it still works, Bob Johnson and Alice Smith. With keyword arguments, the order of arguments, like I said, doesn't matter anymore, because we're explicitly telling Python which value belongs to which parameter. Functions can also return a value to the caller using the return keyword. This value can then be used or stored for later. Let's create a function that returns a greeting message instead of prints it. So when we have this, we can actually just say return, and then remove the parentheses. Now when we run this, we actually don't get any output at all. This is because return doesn't print. When you print, you're actually just printing to the console, and then you can't do anything with this anymore, unless you run it again and just keep printing it. And all this did before was just print. But what if we wanted to store this message in a variable? Well, like we did with other functions, we just do message is equal to greet, and then our function. And so it still doesn't do anything because we just have to print message if we want to see it. And so now we get hello Bob Johnson. So here we're capturing the returned value in a variable called message, and then printing that message. This goes to show that not all functions just print things. If you remember, the isNumeric function actually checks to see if a string is numeric, and it returns true or false, but doesn't print it. The return value can be used, for example, in an if statement or something like that. This is far more useful than just printing something out of the shell. With the power of return statements, you can actually produce a result that can be stored in a variable or used in any manner. This result can be of any data type, and return statements are also a form of control flow. When the return statement's encountered, the function actually ends as well. So this means you can use a return statement prematurely to stop the function during its execution. Without a return statement, the function's result will be lost after the function is executed, and you won't be able to use that result anywhere in your code. But with the return statement, you can actually capture it in a variable, like I said, and use it for anything. So here's another example. We can do our add numbers example again, with num1 and num2. And the variable result will be a local variable that is equal to num1 plus num2, and we can just return result. And down here we can have a variable called sumResult is equal to the output of add numbers, or the returned value of it, 5 and 10. So this would be 15. And we can print sumResult, but we can also print sumResult plus 3 if we wanted. And we could even have another variable called another variable, and that could be equal to sumResult times 2, and this another var could be used for other things as well. And we didn't do anything with another var, but if we wanted, we could print another var like that, and we get the 3 outputs. Beyond just regular parameters, Python also supports non-required or default parameters and functions. These are parameters that have a default value provided in the function definition. Default parameters allow the function to be called with fewer arguments than specified, using the default values for those that are not provided. For example, if you remember our greet example, we can just create a function that takes in a name and then an optional greeting message. So we can define greet, and in here, we'll make sure to enter their name, but message can be predefined as hello, and now we can just print f string formatting, message, and then name. We can greet Alice if we wanted, and we don't have to enter a message, because if we don't enter it, the function will set it to hello. But if we wanted, we can actually change that, and we can greet him with good morning instead of hello. And this would return hello Alice and good morning Bob. That's because the first time we didn't specify what message was. The second time we did. And so the second time we actually set message to good morning. If you remember, print statements are like this as well. For example, the print statements don't even have to have any arguments at all, and if there's no argument, the default is just to print a new line. Or if you did print something, there's another argument called end, and you can set that to something else. By default, it is a new line, but we don't have to enter this because Python already has that set as the default value. But if we wanted to change it for this case, we can set it as a space, and then do another print statement, and it would just say hi hi. So that's just like what these default arguments are. It's optional, you don't have to enter them, but if you want to change it, you can.